Alright guys, welcome to this set of videos. What we're going to do here in this set of videos is we're going to talk about this idea of writing equations of parallel and perpendicular lines. I've been saying over and over again as we've been working our way through geometry that any chance I get to do algebra, we're going to do it. So since here in this chapter we've been talking about intersecting lines, we've been talking about parallel and perpendicular lines, it makes sense we would review from Algebra 1, how do you write the equation of a parallel or perpendicular line. So we're going to go back, we're going to review a little bit of Algebra 1, get some practice just to kind of refresh you guys on how we go about doing that. Writing equations, parallel, perpendicular lines. I love doing algebra, so I'm really excited about this section. Let's just jump right into it. Our essential question is this: how can you find the equation of a line that is parallel or perpendicular to a given line, right? So that's the question we want to be able to answer. And the way that we're going to do that, right, is by going through some problems here where we're going to introduce you guys to this idea. You'll be finding the equation of a line through a point that is parallel or perpendicular to a given line, right? So we're just going to go ahead and do a bunch of these problems. We'll show you how to graph parallel, perpendicular line. Well, first we'll show you how to write the equation of a parallel and perpendicular line, and then how to graph them. Again, like I said, this is review from Algebra 1, so let's just go ahead and jump right into this as I sort of refresh your memory on some things you saw back in Algebra 1. All right away, first thing we should remember from Algebra 1, let me shrink this down just a little bit so we can see it all in one shot. Perfect, there we go. There are two ways to write the equation of a line. Now, I'm not even talking about parallel and perpendicular at this point. Forget parallel and perpendicular lines. There are two ways to write the equation of any line. Any line at all, right? Two ways. You can either slope-intercept form, which is this guy right here. And what you need to remember about slope-intercept form is this. In slope-intercept form, y equals mx plus b. B is going to be your y-intercept. Remember from Algebra 1, the y-intercept is where do you cross the y-axis. That value right there tells you where the line crosses the y-axis. The m is your slope. Now remember, slope is equal to rise over the run. Rise over run, all right? So a line given to you in slope-intercept form, super easy to graph. Really, really easy. You just find your y-intercept, plot that y-intercept, count out your slope. Rise over run. Once you've got 2 points, connect those 2 points with a line and you've graphed that sucker. So slope-intercept form, we'll take a look at that. The second way to write any line, we're not even just parallel and perpendicular, we'll talk about those in a second. Any line at all, you could use the point slope form, which is this guy right here. And here's the way that this equation works, the way this formula works, just like above, m is still going to be your slope, which is the rise over the run. So just like in the slope-intercept form, m is the rise over the run, the slope. It's going to be right there. But in this form, there's two things that you got to watch out for. This y1 and x1. If you take those two guys and put them together, what you're going to get is a point x1, comma y1, right? This is a point. Right? It's a point. So here's the way that this is going to work. If you're ever given a point that the line goes through, right? The line has to go through this point. So if you're given a point the line goes through and a slope, you would use the point slope form to write the equation for that line. And again, we'll take a look at this when we do some example problems, but this is for any line, not even parallel and perpendicular, any linear line, any straight line. If you know a point, and you know the slope, plug and chug. Plug and chug. All right, so 2 ways to write the equation of a line: slope-intercept form, point-slope form. Hopefully, after we've talked about those, you remember them from Algebra 1. Now, parallel and perpendicular lines, here's what you guys need to know. For parallel lines, lines are parallel if, this is key, right? This is conditional. If and only if. If and only if, in fact, I think I highlighted, underlined too much. There we go, right? If and only if, slopes are the same. So they are parallel lines if the slopes are equal. They must be equal. If the slopes aren't equal, they're not parallel lines, okay? Then, perpendicular lines, if and only if, let me underline it again, really, really important, check it out. If and only if the slopes are negative inverses of each other. They must be negative inverses. Inverse just simply means the reciprocal. Here's the way this works. If you have a line that has a slope of, if m is equal to 1/2, then your perpendicular line would have a slope of what? Right? If you have a slope of 1/2, the perpendicular line must have a slope that is the negative, right? Negative inverse. Flip it and make it negative. If it's a positive 1/2, you flip it, make it negative, it would have to be a -2. If you had a slope that was -4, slope was -4, what is the perpendicular line? Well, the slope would have to be, flip it, and make it negative. Negative times a negative is positive. 4 goes to the bottom, 1/4, 1/4. Right? Pretty simple. Let's try another one. If m was equal to, let's say a -1/3, then the perpendicular line would have a slope of what? Well, if m is a -1/3, I have to take the negative reciprocal. Negative times a negative, positive, flip it, 1/3 becomes 3/1 or 3. So the perpendicular line would have a slope of 3, the negative reciprocal. Again, here, let me show you how that works. What I've done for you guys right here is parallel lines. Please notice right here, the slope of this line, y equals 2x plus 5. The slope is 2. Why are they parallel lines? Y equals 2x minus 1. Look, the slopes are the same. 2 and 2. These must be the same. That's why they're parallel. If the slopes are the same, then they're parallel. Here we go. Look, perpendicular lines. I have a slope of 3. In the other line, I have a slope of -1/3. If you take 3, make it negative, and flip it over, take the inverse, you get -1/3. So these guys are negative inverses. Because the slopes are negative inverses of each other, they must be perpendicular lines, right? They must be perpendicular lines. So what we'll do on the next couple of pages of notes is we'll do several example problems where we will just work through, given some information, write the equation of the line, and how we would go about graphing those lines. So head on over to the next page of the notes. I'll meet you guys there.